Welcome to aminacademy.com. In engineering mechanics regarding compound pendulum, let us do some solving problem. Look at this example. A uniform straight rod of length 800 mm and mass 400 gram smoothly pivoted about a point which is 60 mm from one end. Find the period of small oscillation about the pivot if the rod can turn freely in the vertical plane. Here, look at this rod. It is hanged vertically at the pivot point at O, and the rod can oscillate like. Now the given things, mass of the rod. M equal 0.4 kg. Length equal 800 mm, which is equal 0.8 meter. H, the length between the pivot to the end point B is 800 minus 60, which is equal 740 mm, which is equal 0.74 meter. Let I0 is moment of inertia about the point O is equal Ig plus mh square by parallel axis theorem. Now Ig is equal mass 0.4, the length 0.4, that middle half of the length is 800, half of the length is 400, that is zero point 0.4 square over 3 plus mass is 0.4 into h is 0.74 square. Further calculation, this 0.4 into 0.4 square over 3 is 0.0213 plus 0.4 into 0.74 square is 0.219, which is equal 0.240 kg meter square. Now time of oscillation, time period of small oscillation is given t equal 2 pi root I0 mgh, that is 2 pi square root of I0 is 0.2403 over mgh, that is m is 0.4, 9.8 into h is 0.74, which gives t equal 1.82 seconds. Now we'll do next problem. A uniform thin rod of length 800 mm shown in the figure has a mass of 1.5 kg and carries a concentrated mass of 3 kg at B. The rod is hinged at A and is maintained in the horizontal position by the spring of stiffness 2 kilonewton per meter at C. Find the frequency of oscillation, neglect mass of spring. Look at this figure. Here the horizontal rod is pivoted at point A and the free end B have carrying 3 kg and which is supported by a spring of stiffness 2 kilonewton per meter at point C. Now this the disturbing force is given to oscillate like. Now we'll do further calculation. Let M equal mass of the rod is 1.5 kg and mass at B given is 3 kg. Now distance between the point of suspension and the center of gravity H equal H equal that is not H here. First we'll calculate the length of the rod is 0.8 meter. Stiffness of the spring S equal 2000 Newton per meter because 2 kilonewton is 2000 meter. IA moment of inertia about a point A is IA is Ig plus mh square. Ig is mass is 1.5 and zero point 0.8 square, total length 0.8 square over 3 plus mass is mass is 3 kg. Here mass at end point B is 3 kg and to H is 0.8, that is square. So which gives 1.92 kg meter square. Now look at this geometry of the figure here. The rod AB is given small angular displacement as shown in the figure. Now it is oscillating like against the stiffness of the spring. From the geometry of the figure, delta deflection, delta equal the distance, geometry of the figure, 0.4 into sine theta. Here theta is very small, so we can get it. Sine theta is theta, therefore 0.4 into theta. Meter. Now therefore the restoring force about A. The restoring force about A is S delta is S into delta, which is equal, stiffness is 2000 Newton per meter into delta is 0.4 theta, which is equal 800 theta Newton. Now next, therefore restoring moment about A. about A is equal, that is restoring force 800 theta into 0.4 meter, because the distance is 0.4 meter, which is equal 320 theta 320 theta Newton meter. Let it be 1. Next is disturbing moment. Disturbing moment is at A, about A, not at A, about A is I alpha, IA into alpha. Already IA equal 1.92 1.92 into alpha. IA is not 1.92. IA is 2.24. Sorry, 2.24 Newton kg meter square. Here 2.24 into alpha. Let it be 2. Equating restoring moment about A and disturbing moment about A, that is equating 1 and 2, you'll get IA alpha equal 800, IA alpha equal to 320 theta. From this figure, you can get the ratio alpha over theta. IA alpha equal to 2.24 alpha equal 320 theta. Therefore, from this alpha by theta equal 320 over 2.24, which is equal 142.9. Now frequency of oscillation. Frequency of oscillation is given n equal 1 by 2 pi root of alpha over theta, which is equal 1 over 2 pi root of 142.9. So which gives 1.903 hertz frequency of oscillation you got. We have done. Please subscribe our YouTube channel.